Hi everyone. Let's start the session. Before that, I'll just like to add few things about Women Who Code. Yeah, we are Women Who Code Pune team. Basically, Women Who Code is a global non-profit dedicated to inspiring women in to excel in technology careers. This is our vision. So we want women to be proportionately represented in technical careers, and it is an inclusive community. uh, we do not discriminate based on gender identity and expression, or sexual orientation, or ability, or physical appearances, race, ethnicity, religion, caste, or creed. So we can go over the code of conduct. If you are interested, you can go over this. And we also call you to become part of our community as a presenter or facilitator or an audience. So that's about our community. Let me quickly introduce our speaker for today. Today we have with us Prasad Salvi. He is an application security consultant, a certified ethical hacker, and a CISA certified professional with a primary focus on providing services across secure development lifecycle, application security, pen testing spectrum. He is also a part-time bug bounty hunter. He is a blue team expert delivering security training courses to developers and testers to make them proficient in application security and to enable them develop secure products. He has worked with major financial institutions, and he has vouched to create the culture of security. Prasad is also a cybersecurity industry mentor at Stanford University's Advanced Cybersecurity program. Thank you, Prasad, for taking time to give these sessions to the Women Who Code Pune community. Over to you, Prasad.
Thank you, Sena, and good morning, everyone. I'll just quickly share my screen. Can anyone confirm if my screen is visible?
Yes, Prasad, we can see.
All right, thank you so much. So again, good morning and welcome to the session on secure coding proactive controls. As Susanna mentioned, my name is Prasad Salvi and I'm an AppSec consultant at a company called as Total System Service, which was recently merged with an organization called as Global Payments. So a quick introduction, AppSec consultant at TCS, a global payments company. I'm based in Pune, India. Background in network security, VAPT, secure code reviews and audits. The languages that I code is Java, .NET, Python and Ruby. I'm also a security author at Pluralsight. So if any one of you have access to pluralsight.com, I have a couple of courses on penetration testing up on Pluralsight. I also do technical reviews at Pluralsight for the IQ skill test that they have for pen testing. I'm also a freelance podcaster at testskills.com. We make podcasts related to application security and secure coding, which are completely free of cost. As Susanna mentioned, I'm also an industry mentor at Stanford University for the advanced cybersecurity program. I usually, over the weekends, mentor the students and answer their questions or give them real life scenarios, how actually it works in the cybersecurity industry. And I'm into the security field for more than 11 years now. So let's get started. Agenda for today. The purpose of this session is to provide overview of secure coding guidelines for developers. Now, if you're from the QA background, this session will help you on how to find the security issues if you haven't implemented secure coding. Now, using this OWASP proactive controls, we will first define the control, what it is. Then we'll see a few code snippets of both safe and unsafe, or vulnerable code and secure code. And of course, explain how to secure a code. So at the end of this session, you would be familiar with the proactive controls and understand the importance of secure coding. A disclaimer, we are not here to train you on how to code or how to write a code. I'm just going to tell you the different controls while you're performing your day-to-day activities or coding or testing, what are the additional security checks that you can implement so that you don't have to rework if there's a vulnerability, your application be a secure product at the end of your SDLC phase. So these are the proactive controls that we are going to discuss today. Looks to be a lot, but there are only 8, and I'm going to make sure that it's really interesting and we get the maximum out of it. OWASP usually has 10 proactive controls, but I have included the 8 which I felt are very relevant to the development community. The first one is security requirements. I'll just quickly tell about the first one, and then we can move on with number 3 to 10. The first one is security requirements. Now, we do know that we have requirements come in the first place, and then we start designing and coding. But if we don't include security right at the requirement phase, then we are bound to have vulnerabilities later. So OWASP has something called as OWASP Application Security Verification Standard, which is a comprehensive document of requirements, around 200 plus requirements. Now, not all would be applicable to your respective applications, but most of them would be. So it is recommended that you should go through those requirements, and next time you have a requirement coming in from your stakeholders or the product team, make sure the security requirements are also incorporated. The second one is about architecture, secure architecture and design. Again, more from an architect perspective. Now, secure architecture and design, of course, is very important. If we talk about access controls, we'll be seeing more when we talk about implementing the access control later in the session. But access control is a very design heavy control. Now, the architect has to make sure that the architecture that he's preparing for the web application or any application is very secure, and all the extreme checks like brute force attack, for instance, or any account lockouts have been implemented so that later on we don't have any security issues. Now, having said that, let's move on with number 3, which is parameterized query. Now, this is a quick joke that I have on the screen. I'll like give you 5 to 10 seconds to go through it, and I hope you have a good laugh at the end of it. All right, so I hope you have a smile on your face. Now, this is an example or classic example of SQL injection, which has been taken from bobbytables.com. Now, bobbytables.com is a website which helps you with the code snippets to mitigate SQL injection attack in all possible programming languages. If you just hit bobbytables.com on the left-hand side, you will see all the possible programming languages. You click on any of them and they'll show you the secure code or the code mitigation specifically for SQL injection. Now, in this case, she at the end, she says, and I hope you have learned to sanitize your database inputs. But here, as a joke, it is good, but actually to fix SQL injection, only database sanitization or input sanitization doesn't help. So I would say Bobby Tables is wrong, and why? We'll check with the help of an example. Now I have a email ID mentioned on the screen, which is single quote _@wasp.com. So a quick question to this group: how many of us really think this is a valid email address? You can either use our call chat or you can just unmute yourself and say yes or no. Do we have any chats coming in? Because my screen is shared, so I cannot see it. So Sena, you might have to help me here.
Yeah, Steve says it's a valid input.
Okay. Others, do we have any other answers?
Swapnil says no, Bala says no.
Okay, so let's take an example. Now I'm a user of a web. Yeah, sorry, go ahead.
Yeah, Swapnali, I meant to say Swapnali says no.
No worries. So yeah, so we have mixed answers. Some say yes, some say no. So let's try to understand more with help of an example. Now I'm using a web application and I need to update my email address, which happens to be my username of that web application. So I will log into that application, then I'll go ahead to edit profile or my profile, and wherever there's a username field written or email ID field written, I'll enter this particular email address. Now, let's say there is a query which gets fired every time we update something in a profile, where it says update users and set email to the new email that we have given, and ID is a unique random value. Now, when we enter this particular email address, the query becomes something like this in number 3, update user set email to what we have mentioned. So what happens when this query reaches the database interpreter? Now we all know how SQL queries work. Usually the database interpreter will try to identify the single quote where to end the query, right? So if we have given the first single quote in our query itself, the ones in black are the ones that are added by the database interpreter to make it a valid query. Now, when you read this query, or when the database interpreter reads this query, it will identify that, all right, I have the first single quote and I have a second single quote as well. This means that this query needs to end. After that, we have given 2 hyphens. So this, in SQL language, 2 hyphens stands for comment. So everything after this will be commented out, and we would be able to set our email address as a blank email address, or username as a blank username. Now, we all know about HTML5. HTML5 has a regular expression for email address validation. If we only use or depend on that for email address validations, this will be a valid email address. So if we don't want these things to happen, it is better to implement something called as parameterized queries, which is the proactive control that we are going to discuss. Now, parameterized queries has been the best recommendation to mitigate SQL injection attack since a long time. Now, before reaching to parameterized queries, I'd like to tell you a brief about why SQL injection happens in the first place. Now, let's say I'm taking inputs from the user, the username and password, and I'm directly firing it at the backend database to check if it's a valid user without any validations. So if intentionally or unintentionally the user enters something which is not expected by the backend, either it will throw a stack trace if error handling is not being implemented, or it might also log that user in if it is vulnerable to SQL injection. Now, these queries which just take the input from the user and fire at the backend are called as dynamic queries. So in parameterized queries, we code something called as a static query that is mentioned on the screen. Let's say select star from user, where name is @name and password is @password. So basically, instead of directly passing the values we are taking from the user, we create a static query and we create placeholders here. @name and @password are the placeholders that we have created. And in .NET, using the parameters.add function, we take the value that the user has entered in the username text box and assign it to our placeholder. Similarly for the password. So every time when a user enters his username and password, these steps would happen, and then the static query would be fired. Now, when the interpreter sees the static query, it will just fetch the values which have been entered or which have been passed with @name and @password, and try to search the exact value in the database. Now, for example, if I give the username as Prasad single quote, just to see if the application is vulnerable to SQL injection, the database will actually try to find if there's a Prasad single quote in the database, and it wouldn't find that. So it will throw back a generic error saying invalid username and or password. But if we have a dynamic query in that place, the database wouldn't know again where to end the query, and it might throw a stack trace or a database error on the screen. And this helps the attacker to understand what sort of database is being used in the backend. If it's a Oracle database, you see something as ORA colon some error code, which means that the database being used is a Oracle database. So this is how we implement parameterized queries in .NET. For Java, Again, parameterized queries are called as prepaid statements in Java. Same concept, a different programming language, but it does the same thing of helping us mitigating the SQL injection attack. Instead of @name, @password, we have taken a question mark and we have using the prepaid statement dot set string. We have assigned the new name and ID to the parameters that we have taken or placeholders that we have taken 1 and 2, and the same process happens as well. Now, I do understand that everyone in this group has heard or parameterized queries or might have worked as well, which is really great. But still, SQL injection happens to be the topmost vulnerability in OWASP top 10, probably since the inception of OWASP top 10. So why do you think that, everyone knows parameterized queries and how SQL injection can be deadly, but still SQL injection remains to be the topmost of OWASP top 10. So what might be the reason? Anyone? Do we have anything on the chat? I'm sorry. Okay.
Not yet, Prasad.
Okay, no worries. So I'll, in the interest of time, I'll probably give the answer. So what I have seen in my career is usually we do have something on the chat. Sena?
Attacker can bring the system down, someone said.
Okay, that would be the impact of SQL injection. So, I mean, I was trying to say that we know about SQL injection. We know that parameterized query helps in mitigating SQL injection. But still, a lot of applications on the internet or in many organizations are vulnerable to SQL injection. Now, why this happens is this is again my personal experience. What I have observed so far in my career is usually the developers implement all the security knowledge or the controls that they have at very sensitive or critical pages inside the application. Now, let's say if it's an internal banking application, again, the login page will be very secure. Some transfers page would be very secure. Credit card numbers display page would be very secure. But at the same time, there might be a search field uh, within the application after you authenticate. And search field means that you're giving the liberty to the user to search something within that application or probably set something to and from date for his credit card transaction, which means that there is a query being fired for that particular period and fetching the data out of a database for you. Now, usually the search box, which I have observed, is always vulnerable to SQL injection, not always, but most of the times, because again, we are giving the liberty to the users. So we want them to search anything and everything which they want. Again, the user friendliness comes into picture. The more user friendly our application, the less secure it becomes. So that is the reason why SQL injection is so prominent. So usually we fail to understand that from login till we log out, everything should be securely coded. One input which is not sanitized or one text field which is not sanitized, that makes your entire application vulnerable to certain attacks. The next and most interesting control is encode data. Again, I would quickly show you this symbol. Now, this is a script opening symbol or an HTML tag. Now, what will happen if my browser sees this particular tag coming back from the server? My browser would think that anything that is written after this needs to be executed because the server asked me to do so. Now, this is the script tag. Now, let's say there's a username and password field, and I have entered script alert 123, for example, and I've ended the script and I've given a random password. Now, that query would be fired at the database. We have implemented parameterized query. So the database would say, I don't have script alert as my username. So it's an error. I need to throw back invalid user. Now, when the server responds back with an error, but if it also replies back with the username that we have entered, script alert 123, when this response reaches the browser, The browser will check, all right, this is an invalid username and password. I need to show an error on the screen. But all right, I also need to execute a script which the server has asked me to do so. And it will execute that script. And you will see a pop-up on the screen which says 123. Now, this happens because the server responded back with the script tag in clear text. Now, if we encode that script tag and now it looks something like this. If in the same example, if we perform HTML entity encoding, the script opening tag or less than symbol becomes ampersand LT, and the script closing tag or greater than symbol becomes ampersand GT. Now, in this case, in the same example, if the server encodes the input and sends it back to the browser would only show the error as invalid user. It will not execute because this is something that the browser wouldn't understand. It is not something that it has to execute. It is just treated as a string, and we are safe from cross-site scripting attack. Now the pop-up that we see again is cross-site scripting, the most famous attack again. So we'll quickly see an example of stored cross-site scripting. Now again, cross-site scripting has different types: stored, reflected, and DOM based. Now what happens in stored cross-site scripting is what we would see now in this example. So again, let's consider I'm user of an application and I would like to log in as an admin, but I'm still a normal user. So what I would do is I'll log in my with my username and password, and probably in some section of my profile, I'll enter this particular script, and then I'll reach back to the admin saying that I'm not able to log in my profile. Can you just check if there's anything wrong? Now the admin, in order to check that, has to first log in as an admin, and then he'll go to all users, he'll pull up my name, and then while he's logged in as an admin, he'll click on this particular script. Now what this is a very basic script. What we're doing is we are running a HTTP server at attacker's end, and the link says that whoever clicks on this particular script will send his or her document.cookie to the HTTP server that we are running. So while the admin clicks on this, his or her cookie would be sent to the attacker on the HTTP server that he or she is running. And when the attacker would have the cookie of an admin, he can perform something called as session hijacking. And without having the username and password of the admin, he can log in as an admin with that cookie ID. Now, because whenever we authenticate with the correct credentials to a website, the server responds back with a cookie, which would be used for our session until we log out. Now, because this cookie would be a valid cookie, the attacker can perform a session hijacking attack, and then he can be an admin or perform the role of an admin. Now, if we don't want, let's say, the pop-up showing 123 or the session ID, there is something called as an HTTP only directive, which needs to be appended along with your session ID. So when a server responds back to you, it will have a cookie, let's say 123 for example, and it would be followed by something called as the HTTP only flag. Now, if the browser sees the flag HTTP only, even if your application is vulnerable to cross-site scripting, it will still show a pop-up, but it will be a blank pop-up. You won't see a session ID. Again, this is like a compensating control. Now we'll see how we can fix cross-site scripting attack. Now output encoding, as we saw the ampersand LT example, helps us to fix a lot of different attacks, not only cross-site scripting, but I've mentioned quite a few on the screen. Now, why this happens, why it helps us in mitigating different attacks, is because we need to understand, or a developer need to understand that I just cannot enter my name within an input field and say I have hacked your application. I would need certain special characters to see how your server responds to that input. So if you don't have any server side controls, then the server wouldn't understand the input and might behave unexpectedly or throw some errors or give access to some unauthorized content to the attackers. So any special characters that we want in our application, let's say @ is something that I want because I want users to enter the email address. I want a dot or a full stop in that case. So I can create a whitelist of all the special characters that are allowed in my application, and anything and everything that comes apart from that would be rejected straight away by the server. Now, unfortunately, I have seen a lot of organizations, they implement a blacklist, which means they create a huge list of malicious keywords wherein they keep on entering different types of scripts, for example. And when the input comes to the server has to check that input against, let's say, thousands of keywords which are mentioned in the blacklist, and then reach to a conclusion whether it is safe or not. So it is always recommended to implement a whitelist and make sure all other characters would be rejected as is. Now there is also content security policy, but if you get time at the end of the session, I can also talk about security headers. Content security policy also helps in mitigating cross-site scripting attack. But again, that would be a secondary control. The first control or the primary control is to always perform input validation at the client side and HTML or entity encoding or any sort of encoding at the server side. Now, usually I see a lot of developers try to perform customized encoding, and that might create some problems in the application. So instead of that, we can use the OWASP Java encoder project, which I'll reach in the next slide. So this slide talks about XSS defense by data type and context. Now, again, the output that you're showing from the server might be in different context. It might be in HTML context, or you're showing it in the HTML body or in the DOM element. So I have also mentioned the data type, context, and defense in the last column. So for instance, if my data type is string, my context is HTML attribute, I have to make sure that minimal attribute encoding has been performed. Similarly, if it's JSON, client parse time is the context that you're showing in. JSON.parse or JSON2.js needs to be used. Now again, these are the controls which helps us mitigate cross-site scripting in an application. I'll share this deck with Hussaina after this meeting, so she can share it with you all and you have this handy. So talking about the OWASP Java encoder project, again, this is a free library created by OWASP, specially for encoding of special characters in Java applications. We have HTML context, XML, CSS, JavaScript, and UR. I've mentioned a few. It helps in a lot of context. Now, how we implement that is what we'll see with the help of an example. Now, let's say my problem is my web application is built in Java JSP and is vulnerable to cross-site scripting attack. Now, the solution using the OWASP Java encoder project is what I've mentioned for different types of input. Let's say if my input type is text, my value would be encode.for HTML attribute and pass the value that the user has sent across. I think we have some questions coming in, Hussaina, is it?
Someone is facing audio issues, but we are able to hear you well. So I'm asking her to rejoin.
Okay, so shall I wait for some time or we can continue?
So proceed.
Okay. All right. So similarly, if my text area is name, I can use encode for HTML context the text value. So basically, once you import this free library in your code and you just type encode dot, you will see the different context that OWASP Java Encoder project helps you with. And then you have to make sure that for every input field in the application that you're taking the user input has to go through the encoder project. So ideally, every input that the user provides has to be treated as untrusted. We cannot trust any input that is coming from the user. Again, intentionally or unintentionally, the user might enter something which is not expected by the server. So it's always good to treat each and every input as untrusted and implement the controls accordingly. So that was for Java. For .NET, we already have an inbuilt library called as the Microsoft Encoder and AntiXSS library. Again, it encodes in all possible contexts. So if your application is .NET based, please make sure that you're using the AntiXSS or anti-XSS library. Very powerful and well-written library, of course. It also helps in sanitization, which you'll see in a couple of slides. And again, it's a native .NET library. The next control that we have is validate all inputs. Now, all specifically has been mentioned in caps lock here for a reason. Now, I have a screenshot on the screen about TinyMC editor. You might have heard or worked with TinyMC editor. For the folks who don't know, TinyMC editor is a third-party library which helps us to create HTML context. For example, if I give something as an input to the TinyMC editor, it will give me an output in the HTML format of whatever I want. Now, you might reach in a situation which I have been in a lot of times, is when the developers want the users to see an HTML report or a table, for example, on the screen in the browser's context, in HTML context. Now, if they want to show something as a table in an HTML context, they would have to enable the HTML tags so that the browser understands and display it as a table. Now, let's say if to do that, I cannot perform the encoding on that page, because if I perform encoding, the server will send back ampersand LT and ampersand GT, and my browser would treat it as a normal text and it will show garbled data on the screen. Now, as a developer, I have to make sure that the user friendliness is intact, that I'm showing the data as expected in a table in HTML context. But at the same time, I have to make sure that my application is not vulnerable to cross-site scripting. So what are your thoughts? What can we do in this case? I have to make sure that I'm showing the data in HTML context, and I also have to make sure that my application isn't vulnerable to cross-site scripting. So I would just like to know your thoughts.
We identify which are safe HTML tags and not encode them. Like for example, this table example you have given, right? Or the like it, there will be specific tags to achieve tables, right? So
Mhm.
uh, we we can skip them. Maybe we can skip encoding such safe HTML tags.
Okay. Anyone else apart from Hosanna who wants to volunteer? Okay. So Hosanna, you're absolutely right. As a developer, I would know that what are the tags I would need in order to display that particular table. It can be the TR tag, the TD tag, or let's say the heading tag, for instance. So I can create a policy or I can create a whitelist wherein I can only allow these tags. Now, if someone sends a script alert tag or a script along with it to the server should reject that because it is not in the whitelist that we have created. We only expect TR, TD, and heading, for example. And if someone says opening bracket script, closing bracket, it means that someone is trying to perform malicious things on our application, and that input should be rejected. Again, to help us with that, OWASP has something called as HTML Sanitizer project. I've also given the link on the screen. Similar to the Encoder project, this particular project or library helps us with sanitizing the input where we are taking it from a third-party library, like in case of TinyMC editor. Now, because it's a third-party library, the source code of it is not something which we have written or it's not in our control, but we have to make sure that our application is still safe. So we can use the OWASP HTML sanitizer project. Again, high performance and low memory utilization, very simple library which you can again import in your code. Again, an example on how to implement that. My problem is the web page that I've created, let's say the reports.html page, is vulnerable to process scripting because of untrusted input, because I'm taking the input, let's say from TinyMC editor, or someone might bypass the client-side control using a proxy tool and enter something malicious. Now what I'll do is I'll create a policy, a whitelist, and I'll enter all the things which are allowed in my application or the inputs that I can expect in that particular page from the user, or the protocol that I would expect, HTTPS, then allow elements, and anything and everything that you want to whitelist in that page. And in the end, I will use the policy.sanitize function and pass the untrusted HTML that we have received as an input, just to make sure that our application is safe from cross scripting or any other attack. So far we have seen input validations. I mean, we started with SQL injection or parameterized queries, then we saw encoding. So input validation on the client side, encoding and sanitization on the server side is very, very important. If any of these things miss, then your application is vulnerable to certain attacks or a lot of attacks. Usually I see that a lot of developers enter or have all the security controls on the client side, which is a good thing. I mean, I'm not saying that you shouldn't, but the server side, they have not implemented any security. So when attackers, if they perform man in the middle attack, or if the QA folks, if you're on the call, if you know Burp Suite and WhatsApp, you might just intercept the request in those tools, change the input, and then send it across to the server. A basic example of that would be if there's a form on the client side where I'm taking phone numbers from the user. Now, if I enter, let's say ABCD in a phone number, on the client side itself, on the browser, you see a red line which says enter the correct values, for example. Now you enter a phone number and you say submit. Now the request has left the client and it's on its way to the server. Now you capture that request in between using a proxy tool, and you change the phone number to a, let's say ABCD, or you can enter your name, and then you pass it to the server again. Now in this case, if the server does not have any checks or validations implemented, it will just accept that value as a phone number. And on the client side, when you see the response or a confirmation page, you would see a ABCD as your phone number. This means that there is no server-side validations. So client-side controls and server-side controls both go hand in hand if you want to create a secure product. There are a few other HTML sanitizers. Again, for .NET, the AntiXSS library, GetSafe HTML, helps us with the sanitization of untrusted HTML. Again, you don't have to import another library. Unfortunately, Java, we have two libraries, Encoder and Sanitizer. But in .NET, the AntiXSS library helps with preventing cross scripting attack by sanitizing and encoding the input. Again, I'm going to share this deck so you'll have all these links with you. The next one is to implement appropriate access control. So at the beginning, when we spoke about, when I spoke about architecture and design, I spoke about access controls, which is a very design heavy control. Now, I've written a few access control anti-patterns on the screen. So especially hard coding of rules or checks in the application code is a strict no-no when it comes to security. Now, there are a couple of attacks that I would like to talk about in access controls, which we might have done or not intentionally, but unintentionally. Now, let's say if I log into an application and it shows me the URL as example.com/, home.jsp, for example. Now, if an admin logs in, he or she would see example.com/admin/home.jsp. Now, as a normal user, I would only have limited privileges. So I would like to see if I can access an admin user's page, especially the QA folks might do this while security testing. So you can change, or you can try to change the URL and just enter that /admin in between before home.jsp. And if you see an admin's user's page, then it means that the application is vulnerable to something called as a vertical privilege escalation attack. Vertical privilege escalation stands for a lower level user or low privilege user has escalated his privileges vertically and accessed a higher privilege user's page, that is an admin's page. The second type of attack is a horizontal privilege escalation, which means that let's say me and someone else, we both are normal users of that application, and the URL has something called as ID equal to 1. So I change that as ID equal to 2, and I see, let's say, Husaina's page. Husaina and I both are normal users of this application, but just by changing the ID, we both can see each other's pages. Now this is called as a horizontal privilege escalation because we have horizontally escalated the privileges and accessed each other's page. Again, a good example of not hard coding roles. I have an example from Star Wars here. Now, if the weapons that we see in their hand is called the lightsaber. Now, if we hard code the rules, and if we say if user.israel is Jedi or Padawan or Sith Lord or Jedi killing cyborg, then you can use the lightsaber. In this case, we are hard coding the rules within the application. Now, let's say tomorrow we have to change these characters, and there are tens and thousands of lines of code where I have included these hard coding values. Now I'll have to change the entire code or those values, search for those values and change them accordingly. And if an attacker knows that these are the special rules, the attackers would always try to get access or compromise these accounts. So it is not recommended to hard code the rules. Now, how we can implement a secure access control policy. The problem is my web application needs a secure access control mechanism. It is vulnerable to privilege escalation, for example. Now, what I do is once the user logs in, I check his permissions or entitlements, as we call in day-to-day life. And if that user is allowed to use the lightsaber, then he can. If not, then I throw an error, and I also log in my logs that someone tried to access a particular page. Now we'll talk more about intrusion detection and error handling during the last control. But instead of hard coding the roles, we'll have to make sure that we are checking the permissions that the current user has. So even if it changes the URL to /admin/home, the request would still go to the server, and the server will check if the current user is permitted to access the admin user page using his entitlements. If not, then of course there'll be a error message, or he might be redirected to the login page. The next control that we have is establishing authentication and identity controls. Again, very important, or probably the most important one in all the controls. Now I have few snippets on the screen. Now these are different tools which helps us to crack different passwords. Now, when I say crack different passwords, it means that they are stored in certain form in the database, and these help us to crack them. So my next question to this group is, what is the recommendation to store passwords in the database? How should we store them? Certainly, I understand you would say we shouldn't store them in plain text, so that is out of question. So how do we store our passwords in the database? Should we store them as encrypted, or should we store them as hash?
Steve says hashed and salted.
Okay. Anyone else?
Bala says hashed.
Okay. Anyone would like to say encrypted?
Amol says one-way hashing. Raja says encryption.
Mhm. Okay, so we have got a few responses. So uh, before we move on how to store it in the database, let's try to understand the difference between encryption and hashing. Encryption, or any value that is encrypted, can be decrypted back in the plain text. Hashing, on the other way, is a one-way function, which means that once you hash a certain thing, you cannot dehash that, or you cannot get back the plain text value unless you're using a very weak hashing algorithm, let's say MD5. But if we use a strong hashing algorithm, let's say SHA-256 or 512, then it is not possible to get back the plain text value. And I say not possible probably at the moment. Probably with quantum computing, you can even break those as well in the future. So that's the reason that we store the passwords as hashed in a database. It is not recommended to store them as encrypted, because again, if tomorrow my database is breached and the attacker now has all the passwords, if they're encrypted, there is a possibility that he would be able to decrypt them and get the clear text value. But if we have hashed them, then it is difficult for the attacker. Now we'll talk about salt in a bit. Before that, I'll like to ask a few questions or a small game, just to lighten up the mood, especially to the passwords. Now, because we are not seeing each other, probably in your mind you can think of the most critical application that you have, and think about the password. You don't have to say it aloud. Just think about the password you have set for your most critical application. It can be a social media or internet banking. Now I'll ask a few questions and see if your password matches what I'm trying to say. Now, how many of us would have the first character of our password as a capital letter, followed by lowercase letters, followed by a special character, most of the times at the rate, followed by a number or series of number like 1, 2, 3, 4, 5, 6, or 7, 8, 9. Now this is called as a password topology. And if any of your passwords match to what I've just said, then probably you might want to change them, because the attackers know that it's a human tendency to set such passwords. This is called as a password topology. And when they perform brute force attacks, for instance, they try to implement the same topology, because again, it's a human psychology. Now, when we are setting up a password for an application, we usually see the password policy, that minimum 8 characters, uppercase, lowercase numbers, and special characters. Now, it only says that, these things are required. It doesn't say in what order. But because we are so tuned, we usually have the first character as a capital letter, followed by lowercase, and then special character, and then number. Now, this is a password topology, though it's always good to have a mix and match in your password, or now I would say have passphrases instead of password, because when we say that 8 is the minimum what I need to fulfill a password policy or meet the requirements, I'm actually restricting my users, because then as a human, I would only try to match that criteria, the minimum criteria. If the minimum says 8, I'll only have around 8 to 11 characters in my password. But for example, if you have minimum as 16, then the users are forced to keep at least 16 characters as their password. But unfortunately, most of the applications have 8 as minimum and 16 as maximum. So we might want to use passphrases and at least reach that 16 mark rather than the 8 mark. Few password defenses on the screen. I know this slide looks very basic, but trust me, a lot of applications that I have seen, internet banking, government applications, they don't have these basic defenses implemented, unfortunately. Uh, Coming back to storage of password, as someone mentioned, salt. Absolutely. So why we use salt and what is salt and why it is required. Now, again, I'll explain with the help of an example. Now, initially I said that we use hashing to store the passwords. Now, let's say if I have hashed the passwords and they are now in my database. Tomorrow, if that database is breached, now the attacker has all the passwords in hashed format, which he cannot get back in clear text for sure, because I'm using the best hashing algorithm. But what an attacker can do is he can take all the words from the dictionary, make all sorts of password topology that we discussed, and hash all those words. And then he can compare the two hashes, the one that is in my database and the one that he created using a dictionary. Now, if the two hashes match, the corresponding word or clear text word is my password. Now, that's one of the reasons that we say that your do not use dictionary words as your password. Now, if you don't want this to happen, we use something called as a salt. A salt is a unique value which is added to your password and then it is hashed, which makes your password very unique and random. So even if my password is the word password, if I only hash that, it will be easily found in the dictionary. But if I add a unique value, let's say 32 or 64 character value to it, and then I hash that value, then the resulting value or the hashed value would be a completely different one as compared to what the attacker might have from the dictionary. Now that's because the attacker wouldn't know what the salt value is, because that I have generated through my code. In Java, you can use the secure.random function. In .NET, I believe you have the cryptographically pseudo random number generator function, which will give you unique and random values. So script and PBKDF2 are different algorithms which help you to store your passwords safely and securely hashed. I believe Facebook uses PBKDF2 again, but it is very slow and it can take a performance hit. HMAC requires good key storage and very tough. Now what happens in HMAC is, let's say my password is the word password, and now I have a salt. Initially what we do is either we can club them together and hash it, and then we get a value. What happens in HMAC is we first hash our password with one key, we then hash our salt with another, we club them together and we hash that value. So we make it more difficult and more unique. But again, it is very tough and it requires a good key storage. HMAC usually used in mission critical applications or very sensitive passwords. Talking more about passwords, the forgot password secure design. Now, forgot password feature is where we forget a password and usually we go for the security questions that we have set while registering as a user of that application. Now, how many of us really believe that the forgot password questions that we see, the security questions that we see, are actually secure? The most common security question that we see is, what is your mother's maiden name? Now, that's not something which is very secure and only I in this world would know about it. It's very easy to perform a social engineering attack, and someone might just ask me while chatting that what's your mother's maiden name, and without thinking twice, I would just give out that. Okay, so there are few characteristics that we need to keep in mind when we are designing the forgot password feature, which I've mentioned on the screen. The first one, of course, memorable. If users can't remember answers to their security questions, we have actually achieved nothing. Consistent. The user's answer should not change over time. Like for instance, asking what is a significant other, name of a significant other may have a different answers 5 years from now if you're single. Just kidding. Nearly universal, the security questions should apply to a wide audience if possible, and of course safe. The answers to these questions are not something that we post day in and day out on Facebook or on social media, or they are easily guessable. With that, I have created a few security questions which I feel fall under the criteria or the characteristics that we just discussed. I'll give you a few seconds to go through them. All right. So these are the few questions which I feel that can be categorized as security questions. Moving on with the next control, data protection and privacy. HTTPS, of course, HTTPS stands for Hypertext Transfer Protocol Secure. The next question is, what benefits does HTTPS provide? So can anyone help me with that? What benefits does HTTPS provide? Or you can use our call chat. Do we have any answers on the call chat?
Not yet, Prasad.
Okay. So I'll give you a few more seconds. What benefits does HTTPS provide us?
Encrypts the data so it is not sent in clear. Steve says that.
Okay, thanks, Steve. Anyone else? Okay, so I'll quickly show you. So the benefits that we get from HTTPS is confidentiality, integrity, and authenticity. Confidentiality, of course, Steve spoke about encryption. No one can view your data. Integrity is no one can tamper or change your data. And authenticity is server you are visiting is the right one. The lock symbol that we see in the browser means that that website has a valid digital certificate, which means that the website is an authentic one or a secure one. Now, when should TLS be used? This is the question that I usually get from a lot of teams. Now, authentication credentials and session identifiers must be encrypted in transit via HTTPS and SSL. And starting from login till you log out, you have to use HTTPS. Now, there might be instances where you are redirecting your users to different websites. In that case, you can use the HTTP security header called as HSTS or HTTP strict transport security, which instructs the browser to send the traffic over SSL only. So even if unintentionally you type http yourwebsite.com, the browser will change it to https yourwebsite.com. So all the traffic goes over SSL. Now there are a few HTTPS best practices on the screen. One from OWASP, of course, and the second one is from SSL Labs. Very good URLs and write-ups if you want to go through the best practices of HTTPS or SSL. The next one, and probably the last one that we have for today, is error handling, logging, and intrusion detection. So we can turn our applications into an intrusion detection system or application layer intrusion detection system. And how we can do that is what I have mentioned on the screen. If there's an input validation failure on the server side, when the client side validation exists, the phone number example that we saw, if we get a similar example in an application, then it means that someone is trying to bypass the client side control using man in the middle attack. Then it might be an intrusion attempt, which can be logged and can be monitored by different teams. Input validation failure server side on non-user editable parameters such as hidden fields, checkboxes, radio buttons. Now, for example, on the client side, you have 4 radio buttons which the user selects, and on the server side, when you get the request, you suddenly see 6 radio buttons or parameters there, which means that something is wrong. Forced browsing to common attack entry points. We saw about privilege escalations. If someone is trying to enter /admin/ some login.jsp or home.jsp, then it means that someone is trying to access higher users pages or higher privileged users. Other pointers can also be, of course, SQL injection and XSS attacks. Someone entering scripts in the username, or a single quote in the username, or a query in the username, or any input field. It means that someone is trying to perform these attacks. Workflow sequence abuse, multi-part form in wrong order. Like if you take the user details in the first page, on the second page you take some more details, and third page you show the confirmation. But if you directly see the confirmation after the first page, it means that there's a multi-part form failure. Custom business logic, of course, the basket versus catalog price mismatch. If you buy something on a website, and if you see a different price altogether at the checkout than what you have mentioned in initially, it means that someone has tried to perform a man in the middle attack and change the value or the price of that product. Talking about error handling, of course, the most important part. We spoke about SQL injection and how we can avoid giving out the stack traces. This is where we make sure that we have implemented the error handling correctly. A very important aspect of secure application development is to prevent information leakage. Error messages give an attacker great insight into the inner workings and technology and the database that we're using. The purpose of reviewing the error handling code is to assure the application fails safely under all possible error conditions. Now, we should always go for generic errors like system error, please try again later, or contact your administrator. Now, there is something called as a web application firewall or a WAF, which sits in front of your web application to prevent it from different application level attacks, or let's say OWASP attacks, or it also prevents us from showing the stack trace on the browser. Now, even if you have not implemented the error handling correctly and your application is behind a WAF, and if you throw back a stack trace, the WAF will actually block it and show a generic error on the screen. So how we identify if an application is behind a WAF? Usually the WAF have very generic messages or common messages that come on the screen which say something went wrong, this is your ID and a long value, please contact your administrator. When they say this is your ID, this means that the ID has been logged somewhere, let's say in the WAF logs, so the admins can check why this attempt was blocked. So it is very easy to identify if an application is behind a WAF for an attacker. And bypassing a WAF is pretty difficult, but there are new payloads coming up on a daily basis, and at the same time the WAFs are improving as well. So it's a cat and mouse chase. Again, a few best practices for Java and .NET. Again, I'm sure everyone knows about error handling. The only thing missing here or not recommended is to have e.print stack trace on the screen. But make sure that we are catching the errors and putting them in the log files so that we know that why the error happened in the first place. Similarly for .NET, again, throwability, it doesn't have any stack trace message. The last point is to leverage security features of frameworks and security libraries. So as I said, a lot of times the developers try to implement customized code for encryption or for hashing or storage, and they might create some problems in the application. So it's always better to go for open source libraries which have been developed by security researchers, or they have been tested and they have proved themselves. So one of them is Apache Shiro, which is a Java security framework. It is used as a solution to authentication, authorization, cryptography, and session management, and enables custom behavior and secure defaults for everything. So again, in your respective organizations, there might be a process to follow if you want to use any open source softwares, and then if it is allowed, then feel free to raise a request in your organization to use this, so that you can implement that and minimize the customization of code that we write. The next one is libsodium, easy to use software library for encryption, decryption, signatures, password hashing, and many more things, cryptography. Goal is to provide all of the core operations needed to build higher level cryptographic tools. So again, instead of writing custom code for hashing, you can go for libsodium. Cross-platform and cross-language supportive, and runs on a variety of compilers and operating system. Again, follow the respective processes or procedures in your organization and see if you can use this. All right, those were the things that I had for today. If you have been a part of this session for the past 75 minutes, you would probably agree to what I have mentioned on the screen. So while coding or while developing an application, trust nothing, validate everything, think like a hacker, and stay risk aware. So these are the things that I had. I've mentioned my email address, my Twitter, LinkedIn, and Plural site accounts as well. Feel free to connect, and I'm open for any questions that you might have.
Thanks, Prasad. Thanks for all those valuable suggestions and how to implement, like how to follow these guidelines to implement secure code. I think whoever has questions, they can unmute yourself and ask the questions. Manisha asks, is there any certification for OWASP?
No, so OWASP is Open Web Application Security Project. So it's an open source. So there's no certification as such. Everything on the OWASP.org website is completely free to use. So they have something called as an OWASP cheat sheet series, which gives you information about the different secure coding practices on how to mitigate different attacks. So I'll strongly recommend everyone to go through it, especially the developers, the OWASP cheat sheet series, but they don't have a certification as such. Are there any other questions? But if you don't have any questions, then I'm happy to conclude. And thank you for joining, and I hope it was informative. Feel free to connect with me on LinkedIn. If you have any questions, ping me and I'll be happy to answer.
Thanks, Prasad. Thanks once again. I have a lot of learnings I have noted down. At least I will implement them.
Thank
Thanks
you.
again.
Also, thank you, Prasad. Very nice.
Thanks, Pavel.
Okay. Thank you. Bye.
All right. Thank you, everyone. Thank you for joining. Have a nice day.